So ladies and gentlemen, in here, we are looking at second order reactions, still in our series of chemical kinetics, that is advanced chemistry. So what we are going to do, we are going to be looking at direct equation for second order, then we look at half-life equation. All these are going to be derived in this discussion, and then later on we look at the examples of second order reaction. So we proceed by saying that second order reaction is the one in which the reaction is proportional to the concentration of the reactant raised to the second power. So we are saying the rate is equal to K. If we have only one reactant A, then this is going to give us something like this. This is when we have A reacting to give us products. But we can also as well have rate equivalent to K times A times B. And this is when we have A plus B reacting to give us product. Yes. So, either way, when you sum the powers, they should give you 2. So what we're going to do, we are going to consider 1 for simplicity. So we are going to take rate equivalent to K times the concentration of A squared, but we also know that negative the concentration of A by dt is also equal to rate. So if I equate the 2, then that means negative dA, okay, by dt should give me K A squared. So if that is the case, I can say this is, I can do the separation of variables, and I have the concentration of A divided by dt, okay, divided by A squared, and of course concentration of A squared, this is minus, and this is equal to K. This is equal to K dt. Now I'm going to introduce integrals, and I'm going to integrate from the concentration initially at t is equal to 0 to a concentration at any time t. So I'm going to do integrating from concentration of A at t is equal to 0 to concentration of A at any time t. And this is going to be negative dA divided by concentration of A squared, and that is equal to K dt. So what does this mean? I'm going to just move this upwards and make it A to power negative squared, and I mean to power negative 2. And when I doing the integration, I increase the power by 1. So something like this is going to happen. I will have 1 out of A. Okay, so we put in limits at t is equal to 0 and after time is equal to t, and this is equal to kt. Obviously, this was to integrate from 0. And here, this is what is going to happen. I'm going to have 1 out of concentration after time t. Then this is going to be minus, so I'll just take it to the other side and it becomes divided by the concentration of A at t is equal to 0 plus kt. So what does this mean? If I want now to talk about half-life, so I'm talking about half-life, what does that mean? That this t will equal to the concentration of A after a half-life, and this is equal to the concentration at t is equal to 0 divided by 2. So if I bring it in here, I'm going to put it here, 1 out of A, concentration of A divided by 2. This is equal to 1 out of concentration of A at t is equal to 0, then plus K times t a half. So I'm going to move this the other side. Remember, this now becomes 2 divided by A concentration at T is equal to 0 minus 1 out of concentration of A at T is equal to 0 equal to KT a half. So what is this going to be? This is going to be 2 minus 1 divided by concentration of A at T is equal to 0, and this is going to be T. So this is going to be T a half, equivalent to 1 out of the concentration at A, concentration of A at T is equal to 0, divided by K. That is the half-life equation. Half-life equation for second order reactions. So T a half will therefore equal to 1 out of K into the concentration of A at T is equal to 0. So now let's look at the examples of second order reaction. So the examples are going to be three that I'm going to give you. And one is the reaction between hydrogen and iodine to form hydrogen iodide. So one is the reaction between iodine and hydrogen to form hydrogen iodide. So this is a second order reaction. So I will have hydrogen plus iodine, and this is going to give us hydrogen iodide. Another example is going to be oxidation of iodide ions to iodine by peroxide disulfate ion. So oxidation of iodide ions to iodine, obviously by peroxide disulfate ion. Now, this is the peroxide disulfate ions. So we are adding it onto the iodide ions, and we are getting a sulfate and iodine. Can either can put up. Then the next example is the reaction of bromoethane with sodium peroxide. Reaction of bromoethane with sodium peroxide. So this is going to be the bromoethane. We are reacting it with sodium. This is supposed to be sodium oxide. I mean sodium hydroxide. So this is with sodium hydroxide, so that when we add sodium hydroxide in aqueous form, we are forming an ethanol, and we are adding the bromide ion. So those are the examples for second order reactions as per our discussion tonight. Thank you so much.